Hello everybody, welcome to the next video. Today we are looking at exponents and exponential functions, and specifically today we are going to be given a scenario. We're going to have to turn it into an exponential function, and we just need to write it in a specific function notation. So let's take a quick look at question number 15. It says the population of snails in a tank at the aquarium is found to triple every year. Mark visits the aquarium and counts 80 snails in the tank. Write a function f of n to model the number of snails in the tank n years after Mark's visit. And they give us f of n equals the function part we need. So there is one key word here that tells you this is an exponential function, and it is this key word triple. When you hear words like double, triple, quadruple, that light bulb should go off for exponential function. So we're just going to start quick with the general form of an exponential function. And if you remember that, it is y equals a times b to the x, where a is your initial population, and b is your growth factor. Now, in this case, we are going to be working with specifically growth because it is doubling or tripling in this specific case, so we're going to have a growth factor. Now, when we look at those numbers that we're given, our initial population, well, they tell us we start with 80 snails. Then they say the growth factor, well, since it's tripling, that's just going to be 3. So if we replace the parameters a and b with the numbers 80 and 3, we have y equals 80 times 3 to the x. Now we just need to quickly turn this into function notation where n is our input instead of x. So we have the output f of n, where n is our input for number of years, equals 80 times 3 to the n. This is actually your correct answer, but I know a lot of you are probably sitting here thinking, I might not remember that general form for a function. So let's look at how we might be able to remember this just by going through the steps. So if you build a table of values where we have n for the number of years, and whatever this function is going to be, we'll say that's the output. Well, at 0 years, if no time has passed, I think we all agree Mark still sees those 80 snails. But now if 1 year has passed, then we have to say, well, you're going to take that 80 and it's going to triple, so times 3. Now, if that happens again, let's say 2 years have passed, well, then you're going to take that 80 and you'll say times 3 again. Maybe we want to rewrite this now because we want to use exponents. So this is the same as 80 times 3 squared. This one above was the same as 80 times 3 to the first. And if we continue this process, you see that we can get 80 times 3 times 3 times 3 equals 80 times 3 to the third. Now the key here is that the number of years is now directly lining up with the exponent here. So if we continue this pattern and we say, well, after 4 years, it should be 80 times 3 to the fourth. Now here's the big jump, because we want to keep this open. Let's keep this open for any number of years n. Well, following the same logic, if we are just using the number of years as the exponent, this should be 80 times 3 to the n. And that is how we can relearn what the function is, the exponential function. We now know that f of n is the same as taking the number 80 and multiplying it by 3 n number of times for the number of years. And that would be your final answer. So we would just type that in here as we see, 80 times 3. Then we're going to have to use the little caret symbol here, and n. And there's your final answer. Thanks again for another great video, everyone. Please go ahead and click subscribe down below. Don't forget to do that extra little practice question too. You're going to see something just like this, maybe with a slightly different growth factor. So see you again next time. Thanks, everyone.